Problem 214, Thermodynamics and Statistical Physics. The question is, the pressure of a non-relativistic free Fermi gas in 3 dimension depends at T is equal to 0 on the density of fermion n as. We have in 3D, the Fermi energy EF is given by h cross square by 2m 3 pi square n by v raised to 2 by 3, and the total energy U is equal to 3 by 5 NEF, and the pressure of the gas P is equal to minus dou U by dou V at a constant n. First, let us write the total energy of the gas U as 3 by 5 NEF. What is EF? EF is the Fermi energy in 3D, and that is given by h cross square by 2m 3 pi square n by v 3 pi square n by v raised to 2 by 3. Therefore, now in the above expression n by v is equal to n, where small n is the number density or the density of fermion. It is the number of particles per unit volume. The density of the fermion is given by small n. Now what is the total energy U? U is equal to 3 by 5 NEF, that is equal to 3 by 5 n h cross square by 2m 3 pi square n by v raised to 2 by 3. Now let us rearrange the term. We have the total energy U is equal to 3 by 5, then 3 pi square raised to 2 by 3. Let us take all the constant terms outside the bracket. Then we have h cross square by 2m. Then n raised to 2 by 3 into n, that is n raised to 5 by 3. Now we have v raised to minus 2 by 3. This is the expression for the total energy of the gas in 3D. Now our aim is to find out the pressure of the gas. The pressure is given by minus dou U by dou V at constant n. So we have to differentiate the above expression with respect to V, keeping capital N constant. Or P is equal to minus dou by dou V. P is equal to minus dou by dou V. Now within bracket we have the expression for the total energy U, that is 3 by 5 3 pi square raised to 2 by 3. Then h cross square by 2m n raised to 5 by 3, then v raised to minus 2 by 3. Now we have to differentiate these terms inside the bracket. So first of all, let us take all the constant terms outside the bracket. Now we have the expression for pressure becomes 3 by 5 3 pi square raised to 2 by 3, 3 pi square raised to 2 by 3. Then we have h cross square by 2m. Since n is a constant, we can also take n outside, then n raised to 5 by 3. Now differentiate v raised to minus 2 by 3 with respect to v, that is minus 2 by 3 v raised to minus 2 by 3 minus 1, that is minus 5 by 3. Now let us rearrange the terms so that the pressure is 3 by 5, minus and minus, negative and negative cancel, 3 by 5 into 2 by 3, that is 2 by 5, h cross square by 2m, then 3 pi square raised to 2 by 3. Now let us club n raised to 5 by 3 and v raised to minus 5 by 3 as n by v raised to 5 by 3. N by v raised to 5 by 3. We have n by v is equal to small n, that is the density of fermion. So our expression for pressure becomes P is equal to 2 by 5 h cross square by 2m, then 3 pi square raised to 2 by 3. Now replace capital N by V as small n, where small n is the number density, n raised to 5 by 3, where n by V is equal to small n is the number density. This is the final expression for pressure of non-relativistic free Fermi gas in 3D. So we have the conclusion that the pressure is directly proportional to the density of fermion n raised to 5 by 3. Hence, from the given option, option A is the right option.